Hello everyone. In this question, it is asked that we are to find the number of integral solutions that satisfies the inequality x upon x plus 6 is less than or equal to 1 upon x. Okay, so let us first start. The inequality is x upon x plus 6 is less than equal to 1 upon x. Okay, so let me take all the terms to the left hand side. So this now becomes x upon x plus 6 minus 1 upon x. This is less than or equal to 0, right? Okay, so if I take the LCM now, it will become x square minus x minus 6 upon x times x plus 6 will be less than or equal to 0, right? So let me try to factorize this numerator. So the product is minus 6 and the sum is minus 1. Okay, so minus 3 plus 2. So this will become x minus 3 times x plus 2. Okay, minus 3x plus 2x minus 6. Okay, upon x times x plus 6 will be less than or equal to 0. Okay, so if I try to write it in the standard x minus some term in the factors, this will become x minus of minus 2, this x plus 2 term, times x minus 3, and in the denominator it is x times x minus of minus 6 less than equal to 0, right? Okay, so this inequality, after factorizing, we see that this inequality is defined. Okay, this, let me write it as this one as 1. Okay, this inequality 1 is defined if and only if x not equal to 0 or not, or sorry, it should be and x not equal to 0 and x not equal to minus 6. Okay, because if this becomes 0, if either of these terms becomes 0, this becomes meaningless, right? Something divided by 0, this becomes meaningless. It is not defined in real number system. Okay, so the domain is now r minus 0 comma minus 6. Okay, this is the domain. So we have to find the integral values of x that satisfies this inequality. Okay, and this cannot have these two particular values, 0 or minus 6. Okay, so after factorizing in the numerator, we get this x minus minus 2 and x minus 3. So we see the critical points. The critical points that we need to observe carefully. Critical points are this denominator cannot be 0, minus 6, and the numerator becomes 0 when either of these terms is equal to 0, right? Either of these factors is equal to 0. So either if x is equal to minus 2, then this will become 0, or if x equals 3, then this will become 0, right? So the other two critical points are minus 2 and 3. Okay, the other 2 points are like, if I just equate the numerator to 0, x plus 2 times x minus 3 equal to 0, this will give me the critical points minus 2 or 3. Okay, so these are the other 2 points. Okay, so if I draw a number line down, okay, I write my minus 2 somewhere here, 0 here, and let's say 3 is here. Let's say this is minus 6, this is minus 2, this is 0, and this is 3. Okay, so these are the 4 critical points in this inequality. Okay, so again, if I observe this inequality 1, okay, if I write 1 again, 1 is x plus 2 times x minus 3 upon x times x plus 6, this is less than equal to 0. Okay, so if I observe these critical points, okay, I have this region, this is region 1, which is to the left of minus 6. Okay, I have this region 2, which is between minus 6 and minus 2. I have this third region, which is between minus 2 and 0. This fourth region, 0 to 3, and this fifth region, which is to the right of 3. Okay, so I will analyze each of these regions and see which one satisfies this inequality. Okay, so for the first region, if I take x equal to say minus 7 and I put it here, okay, then let me investigate the left hand side. Okay, the left hand side will become minus 7 plus 2 is minus 5, and this will become minus 7 times minus 3 is minus 10, and this will become minus 7 times minus 7 plus 6 is minus 1. Okay, so this will give me this minus 5 times minus 10, this is a positive number, right? And this minus 7 times minus 1, this is also a positive number. So this fraction, this will be positive, right? So this cannot be less than 0. Okay, this is not less than 0, not less than 0. So this x equal to minus 7, this part, this is giving me a positive value. Okay, so this does not satisfy this inequality one. Okay, so I will come to this second region now. Second region lies between minus 6 and minus 2, but minus 6 is excluded. This is excluded and 0 is excluded. Okay, because this will these 2 points are undefined. See, the domain is r minus 0 and minus 6. Okay, so these 2 points are excluded. So for the second region, I will take another value in between minus 6 and minus 2. So let me take the value to be minus, say minus 3. Okay, if I take x equal to minus 3, this equation 1 will now become minus 3 plus 2 will become minus 1, and minus 3 will become minus 6. And in the denominator, it is minus 3 times minus 3 plus 6 is plus 3, right? So if I look at the sign, the numerator is negative times negative, so this will become positive again. And this negative times a positive, this will give me a negative number. Okay, and the ratio of a positive and a negative number, this is negative. So this is a negative number. Whatever the value it is a negative number, right? I don't need the magnitude, I just need the sign. So this is again a negative number which is less than equal to 0. So this is in the solution domain. Okay, this is the domain, this r minus 0 comma minus 6. Okay, so this satisfies the inequality. So this one, this gives me a negative, right? So this is in the solution domain. So this region 2, this is this is applicable for the current inequality. Okay, so this minus 6 to minus 2, how many integers are there here? Okay, if x belongs to minus 6 comma minus 2 included, minus 6 is excluded but minus 2 is included, so this will give me x equal to minus 5 comma minus 4 comma minus 3 comma minus 2. So I get 4 solutions from this region. Okay, from this interval I get 4 solutions. Okay, so I will now look at this other 3 regions for the other solutions. Okay, so the third region, let me take another value from this region. This is minus 2 to 0, and 0 is excluded. Okay, so let me take minus 1. So if I take minus 1 and I plug it in this inequality, x plus 2 times x minus 3, let me see what happens. So minus 1 times minus 1 plus 2 will give me a plus 1 in the numerator. And then minus 1 times minus 3 will give me minus 4. Minus 1 minus 3 is minus 4. And this is minus 1. And then minus 1 plus 6 is plus 5. Okay, so the product is now negative in the numerator, and this is again negative in the denominator. So this will give me a positive number again. Okay, irrespective of the magnitude, this will give me a positive number. So this positive number is again not less than equal to 0, right? So this is greater than 0. So this is not less than equal to 0. So this is not in the region. Okay, this again gives me a positive value. but I only need the negative values. So one of them is this section 2. And now I will look at this section 4 and 5 and see if there are anything else available for the given solution set. So for the fourth region, this is from 0 to 3, where 0 is excluded. So if I take the value 1, if I take x equal to 1, okay, here I took, in the third region, I took x equal to -1. Okay, if I take x equal to 1, I will get 1 plus 2 is 3, and 1 minus 3 will be -2. And 1 plus 6 is 7. Okay, so again, positive and negative product in the numerator, so this will be a negative number, and the denominator has only positive term, so the product will be positive. So now we get a negative upon a positive number, so the fraction will be negative. So this is again less than equal to 0, so this will give me another solution set, right? This will again give me a solution set. So this value, this region has negative values, so this will give me a few more integer solutions. So let's see what are the integer solutions here. Here x lies from 0 open interval to 3 included, 3 closed. Okay, so x belongs to 0 excluded and 3 included. This will give me x equal to 1, 2 and 3. So again, 3 more integer solutions. Okay, I had 4 here before and 3 from here. Okay, so far we got 7 solutions, 4 plus 3. Okay, now I need to check this last section, this 3 to infinity. Okay, to the right of 3. This is the last section. Okay, so if I take x equal to 4 here in this inequality, x plus 2, let's see what I get. Okay, x equal to 4, so 4 plus 2 will be 6, and 4 minus 3 will be 1, and 4 plus 6 will be 10. Okay, so this is positive and this is positive, so this is actually positive upon positive, so no chance of being negative. Okay, this is not less than equal to 0, so this is positive, so again no solution from this region. Okay, so this section 5, this is also positive, so the solution region is here and from here in sections 2 and 4. Okay, so the solution region is x belongs to this -6 to 2 included union 0 to 3, where x is integer. So this gives the solution set x equal to -5, -4, -3, -2, 1, 2, 3. Okay, so this is the solution set which satisfies this inequality. Okay, and we have to find the total number of integral solutions. So therefore the solution set is this, right? So therefore number of integral solutions equal to 7. Okay, so this is the final answer. Okay, so I just plugged and checked the values in each of these sections, which I split up after finding the critical points. Okay, these 4 are the critical points here, and after that I just split them up in a number line and just plug the exemplar values in each of these from each of these sections in the original expression, and saw if they satisfied the inequality or not. Okay, so this is it. You just see the sign from each of these sections and see whichever satisfies the given inequality accordingly. Okay, so there are total 7 solutions. Okay, so this is the answer. Thank you.